pick your formulas. All right, we're using 3 variables for most of our conceptual physics work. All right, 3 variables at a time. We do force. We'll have forces, mass, acceleration. That's 3 variables. Right now we're doing velocity. Velocity or speed is a change in position during a time period. So we have speed, we have distance, and we have time. Those are 3 variables. On top of your paper, draw this. Draw a nice big circle. Put a line in the middle, right? And what we'll have is we'll have distance, d, little d. We'll have speed or velocity represented as a v, and we'll have time right there represented as a t. Now this is written in such a way that when you're looking for a variable, I'm looking for distance. If I want to know what the distance is, all right, I cover it up. I'm looking for distance. What equation do I use? Speed times the time. All right, if I'm looking for the velocity, we have
distance divided by
we have the distance, the total distance divided by the time. If I'm looking for a time interval, good, distance divided by speed or velocity. So this is used to help us determine which formula we're going to use. Whatever you're looking for, whether it's distance, velocity, or time, you cover that up because you're looking for it. You're looking for it, and that gives you the equation you use to solve that problem. Our first problem that we have here is about a polar bear. Polar bears are extremely good swimmers and can travel as long as 10 hours without resting. If a polar bear is swimming with an average speed of 2.6 meters per second, how far will it have traveled after 10 hours? All right, I read the question, and at this point I kind of understand what they're saying, right? What am I looking for? Distance. So, distance is equal to what in our equation? Speed times the time, right? So we have distance is what we're looking for, is speed times the time. All right, so what is our speed or velocity? That was 2.6 what? All right, m/s. And although what we're used to seeing in our cars is mph for miles per hour, we're using the metric system, and this is meters per second. Meters per second. Now, if we ever in a physics book, if we're ever looking for the abbreviation for miles, they'll use little m, little I. I know this isn't exactly how we do it in our automobiles, is it? In our cars, we do mph, miles per hour. This is meters per second. Meters per second. So when we're doing the physics out of these books and out of these problems, we're going to use the metric system, which is meters and not miles. So we have our speed, 2.6 meters per second, and now we need to know what our time interval is going to be. 10 hours, okay, 10 hours. All right, now, this is a sample problem, so here's what I'll tell you. When we do our equation solving, when we do our problem solving, we need to make sure our units are all in the same order. Now, doing physics, it's commonly considered the MKS system. MKS stands for meters, kilograms, and seconds, time in seconds. And what that means is that when we do, not so much now, but when we do forces with newtons, that's kilograms, meters, and seconds squared. All right, when we do joules of energy and do other things, we will need to convert more than likely everything to meters, or seconds, or kilograms when we talk about mass. Right now it's not as important, but the reason why we need to do those conversions to create the MKS system is because in order to solve a problem, we need every unit to be identical in that dimension. So in the dimension of time, we need to have the same units, do we? What are the units of time that we're using here? Seconds, yes. And hours. Are they the same thing? Is a second the same as an hour? So we have to convert one of these to the other. It's easier to convert the hours to seconds. I'm going to ask Mike and Mike only. When we do the factor label method, all right, we put down what's given to us, 10 hours. We put down what's given to us, 10 hours, and we want to convert it into, we're going to want to convert it into seconds. I'm going to use SEC for seconds, even though we could just use S. I'll just do it just so it's more familiar with it. So, do you know how many seconds are in 1 hour, Mike? No. Okay. Well, do you know how many minutes are in 1 hour? How many minutes are in 1 hour? All right, so we'll go halfway there. 60 minutes are in 1 hour. That's true, isn't it, Mike?
Yeah.
All right, so we're halfway there. Do you know how many seconds are in 1 minute? 60 seconds are in 1 minute. All right, you remember this, right? You guys remember this factor label method? Yes? All right, so basically it's already all set up. Now we just do the math. All right, if it's all on the top line, we multiply. If it's on the bottom line, then we use that, we divide with that. Right? Numerators and denominators, remember that?
Yeah.
Okay, all right. So hours, hours, minutes, minutes. And Mike, how would I read this? If I had a calculator, you do have a calculator. Why don't you take it out of your mouth and open it up and hit the on button. And give me an answer for this. 10, what does this mean? 10 what? 60. All right, 10 times 60 times 60 equals. We need to use seconds, and we're going to write that as 36,000 seconds. So now we have time in seconds, and we have speed in meters per second. So the time units are seconds and seconds for both of these, right? Meters per second is seconds, and seconds are seconds. So all we have to do to solve our problem is speed times the time. So D equals 2.6 meters per second times 36,000 seconds equals 93,600. And what would this be now? This is distance. We would call that seconds. Do we keep distance? Meters. Meters. All right, we have meters per second, seconds. Time, when I use my watch, it'll be seconds, minutes, hours, calendars for days, months, years, right? That's time, right? Distance would be meters, maybe miles, kilometers, centimeters, millimeters, hectometers, decimeters. Speed is a derived unit, which means it takes 2 units. We take distance covered in a time interval. Rate. Distance covered in a time interval. So speed or velocity will always be meters per second, or kilometers per second, or kilometers per hour, or miles per hour. It'll be two dimensions, right? Length and time, right? Derived into 1 unit. The meter second. Meter per second, not a meter second, it's a meter per second. All right, so you got that? Problem number 1. Let's read this. It says, suppose that polar bear were running on land instead of swimming. If the polar bear runs at a speed of 8.3 meters per second, how far, Mike, will it travel in 10 hours? Alec, how far is asking us what? Distance. And if we're looking for distance, what equation do we use? Okay, so write that down. D equals V times T. So you write that down right next to number 1. Now, yeah, speed. What is the speed of this polar bear running on land?
8.3
8.3 what?
miles per second.
What is it?
Miles per second.
Is it miles per second?
Meters.
Meters. 8.3 meters per second. So that's our speed. And what is the time interval? 10 hours. What is the time interval we're going to use?
Seconds.
Seconds. How many seconds are 10 hours?
36.
Very good. 36,000 seconds. Now, will it ever change if I have another question? Could it be maybe 50 seconds in 10 hours?
No.
You know, it's always the same, right? Always the same. So, 36,000 seconds. So how do we solve this problem? So what's the answer? 298,800. Is that right? And what is this? Is this Did you use 8.3? Try it again.
298,800 meters.
Is this right?
Yeah.
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 And it's meters?
Mm-hmm.
Excellent. Meters. Meters. So you guys wrote all this down? So now go on to number 2, called the factor label method, conversion factors. All right, so I'll do this right here. Time. What do we have? 3.4 minutes? 3.4 minutes. Now, first of all, do we have to convert it to seconds? Why? Because the speed is meters per second. What is the speed? 9.7 meters per second. And up here we need this v times t again. So here's all this stuff set up. So this was the first part I asked you to do. Don't skip these steps. All right, don't skip these steps. The first thing I want you to do is to here's your formula. This is what speed is. This is what time is. All right, seconds a minute. We need to convert it. So here's my conversion factor. Here's my conversion factor. If this was 1 minute, how many seconds would it be?
60.
If this was 2 minutes, how many seconds would it be? How'd you get that?
9
Plus 60.
60 plus 60, or 2 times 60. Same thing.
Yeah.
If this was 3 minutes, how many seconds would it be?
180.
180.
Because it's what? How would you find that? 60 times 3. If this was 4 minutes, what would it be? How many seconds?
2,600.
You got a calculator, you don't have to think about it.
240.
All right, 240. So, how did you find that?
Multiplying it by 4.
60 times 4. So this is 3.4 minutes, so how would you find an answer?
3.4 times 6.
3.4 times.
All right, so let's see. Here's my conversion factor. Let's see if that agrees with what we're doing. Minutes, we're given minutes, M-I-N. We want to know seconds. Right here, seconds. How many seconds are in 1 minute? 60. So 3.4 times 60 equals, who's got a calculator?
I do.
What did you have?
204.
204 seconds. Yeah, 204. 204 seconds. 204 seconds. All right, so you see that? You see how that is? All right, now, do you know how to solve this? Now that you know that time is 204 seconds and the velocity is 9.7 meters per second, do you know how to solve this? So what's your answer?
1,900.
Use the calculator. 9.7 times 204 equals
197.
E equals 9.7 times 204. And Dina, what do you got?
213.7.
213.7?
No.
Oh, I added it, my bad.
197.
Dina? Dina?
1,978.8.
What? 1,978.8 seahorses?
Meters.
Meters.
Pull the figure.
Excellent. Anyone disagree with that?
No.
Do number 3 by yourself. Don't look at me. Don't look at me. Don't look at me for answers. Number 3, write down what the speed is, write down what the time is, and then solve it. And I'll call on someone to come up here. Step number 1, read and understand the problem. Dina, you read and understand the problem? D equals, V equals under it, and T, no. D equals, V equals, and T equals. Now fill in from this problem what V is, what T is, and what equation you're going to use for D. All right, Dan, why don't you go up there, put the V and the T on the board, Dan. Go up there, put our speed, what our speed is going to be. Do the speed first, just write it up there. V equals all right, step back for a second. How many people don't have this 121 km per hour? You don't have that? How come? What do you have? Anyone else not have that? How come?
I put 75 on.
All right, you put miles per hour. But look what it's asking us. Remember when you read it, it says the maximum posted speed limit in the U.S. interstate highway may be found in rural areas of several western states. The maximum speed is 75 miles per hour or 121 kilometers per hour. So you have a choice here. You could use 75 miles per hour or 121 kilometers per hour. Yes. The next sentence says, what is the distance in kilometers traveled by a car moving continuously at this speed for 3.3 hours? So, if we want to determine what it is in kilometers, are we going to use miles per hour or kilometers per hour? All right. Now, what's the time, Dan? .3 hours. So, Dan, to solve this, we just take V times T equals, right? So go ahead and do that and then put the answer up there. All right, for normal situations, the minimum speed limit throughout the U.S. interstate highway system is 45 miles per hour or 75 kilometers per hour. How far in kilometers will a car travel that is moving continuously at a speed of 3.3 hours? Or at the speed for 3.3 hours. So what is the time we're going to use? Yes? 3.3 hours. And what is the speed we're going to use? 72 kilometers per hour. km per hour. And when I do this little D equals V, 72 km per hour times 3.3 hours equals, what's our answer, Mike? 72 times 3.3 equals, you got a calculator. All right, number 5 we're on. We're on number 5. DeMarco, let me read this to you. We're on number 5. The various types of tree sloths share the honor of being the slowest moving mammals. An average tree sloth moves with a speed of 0.743 meters per second. How long does it take a sloth moving at this speed to travel 22.30 meters? All right, do we know what the distance is of this sloth, DeMarco? What is the distance? Meters per second, is that how we do distance? What do we use for distance?
The meter.
Meters, right? I measure distance with a meter stick. All right, what do I use for time? Seconds. And what do we do for a derived unit like speed? Meters per second. Meters per second. So the distance, DeMarco, look in there. Read and understand the problem. We're looking for the distance covered. We're looking for the distance covered. How far? What is that number given to us? Yes, 22.3 meters. 22.30 meters. All right, so now the speed of this slope, what do we have for that? That would be meters per second. Meters per second. What would we have for that? 0.743 meters per second. Now, this is in meters. This is in meters per second. Meters per second. Do we need to convert anything?
No.
No? Right? So we're looking for time. Ooh. We're looking for time. Look at here. Put your finger over the little T on your circle sheet. And what's left? Mike? Distance and velocity, but how's it written? Distance divided. So T equals distance D divided by velocity V equals distance 2.30 divided by 0.743 meters per second.
Oh, I know.
Meters. All right, you got a calculator? I hear an answer. We're on number 6, right?
Yes.
The longest stretch of straight railroad tracks lies across the desolate Nullarbor Plain between Australian cities of Adelaide and Perth. Perth, Australia, that's where they have an observatory that if you're in a science club, you can use to look at quasars. I don't know if you know that. After school Mondays, not today, next Monday. The tracks extend a distance of 478 kilometers without a curve, that means straight. How long would it take a train moving at a constant speed of 97 kilometers per hour to travel this length? So what are we looking for?
The distance.
Is it how long
No.
No, the
it
time.
takes? The time. So time is equal to what?
Distance divided by velocity.
All right, distance divided by velocity. What is the distance that they give us? How long? It says a distance of what?
478 kilometers.
478 kilometers. And the speed, a constant speed of what?
97 kilometers
Per hour.
per hour.
97 kilometers per hour. So distance divided by speed. 478 divided by 97. You guys are almost done. Number 7, go ahead. Start on it yourself. Number 7. Yeah, in your head, write it down. That's okay. Number 7, what do we have here? Mike, what was the distance that the Concorde traveled? 6265. 6265 kilometers, very good. And what was the speed that it traveled at? Kilometers per hour. So, what is distance? 6265 divided by 2150 equals what, Mike? 2.91 what? Hours. Hours. Okay, good. So, everyone get that?
Yeah.
Yes? 8. I got it written up here. That was number 7. Number 8. Is anyone, Dina, did you do 8 already?
No, I didn't.
Did you do 7?
Yes, I did.
Is this what you got?
Yes, I did.
Now do 8. remember, we do this in class, you don't do it for homework. You stare at me in class, you do math for homework. We don't have a lot of time, so let me read number 8. The longest distance of a field and track event is 10-kilometer run. The record holder for a woman's 10-kilometer run is Wang Zhengxia of China. Assuming that Wang Zhengxia ran a distance of 10 kilometers with an average speed of 5.644 meters per second, what was her time? So what is the distance she's going to run?
10 kilometers.
Yeah, they said it 3 times. 10 kilometers, 10 kilometers, 10. She's going to run 10 kilometers. I know it's confusing because they put it in there, but that's read and understand. Read and understand. Now, what is the speed that she did it at?
5.644 meters per second.
All right, 6 meters per second. All right, so distance divided by speed equals 10 divided by 5.644 equals, anyone? Anyone?
I got it.
56?
0.5644.
All right, wait. Shh. Whenever we get this, instead of just staring at it, let's look. Look what I got here, Dina. All right, calculator. Clear? Get ready. You ready?
You don't do.
1, 0, divide 5.644 equals.
Don't you gotta make it into meters?
You see that? Look at this. 10-kilometer run, meters per second. You have to change this. Look at this. You have to change this. How many meters are in a kilometer? 1,000. So how many are in 10 kilometers? 10,000. We have to change this to 10,000 meters, which means this is meters per. Why do we have to change that from kilometers to meters? Yeah, we got meters here, we got meters here. Meters and meters. Meters and meters. Right?
Yeah.
Meters and meters. So we have to change that.
Oh, but there's no difference in answer.
No, it's going to be a different answer, isn't it? So we got 10,000, 10, 0, 0, 0, 0. Divided by 5.644 equals what?
Oh, no, it's not.
6,000.